going to do a video on I'm going to do a video on inequalities, but specifically something that looks like this. If I had x is greater than or equal to 3, I would put a closed circle on the 3 to show that the value 3 is in fact included. I'm going to color it in, and then I'm going to draw an arrow going towards the x. And the reason why is because if I took a look at some x values, if I took a look at I'm going to say x is greater than or equal to 3. If I take a look at 0, is that true? No, 0 is not greater than or equal to 3. 1, not true. 2, not true. But when I get to 3, 3 is greater than or equal to 3, so yes, that is true. So that works. 4 works. 4 is greater than or equal to 3. So we're in some pretty good shape. Now, I'm going to take a look at something else. This says negative x is greater than or equal to 3. And now, if I take a look at my x values again, I get negative x is greater than or equal to 3. So let's take a look at some values. I'm going to take a look at the value 0. Is negative 0 greater than or equal to 3? And the answer is no. I'm going to take a look at 1. Is negative 1 greater than or equal to 3? Here's negative 1. Oh, here's 3, right? I just want to make sure everybody realizes that. Here's negative 1, and that's here's 1, and that's obviously not true. When x is 2, this becomes negative 2 is greater than or equal to 3, and that's still no. So now you might be thinking, well, wait a second, how come? Oh, well, and those didn't work for the other one anyway. So let's see. Now 3 should work, but let's see what happens. When I put this in, I get negative 3 is greater than or equal to 3, and that's still no, because negative 3 is way over here, and that's obviously not greater than or equal to 3. So now, when x equals 3, all right? Yeah, have to keep that in mind. We're still talking about this x value. So now I'll try 4, and let's see what happens. If x is 4, this becomes a negative 4 is greater than or equal to 3. And that's still not true. So you might be saying, whoa, what's going on here? Well, let's take a quick look at some other values, all right? So we just said 0, 1, 2, 3, and 4. None of those worked. So what I'm going to do is I'm going to take a look at some other values. And let's see what happens when I try negative 1. Well, now I have a negative 1, and that's going to be 1 is greater than or equal to 3, so that's still no. Negative 2 becomes a negative 2, which is a positive 2, and 2 is still not greater than 3. Now I'm going to try negative 3, and then negative 3 is greater than or equal to 3. It's 3. So this works. Oh, all right. Negative 4 becomes a negative 4 is greater than or equal to 3. And that also works. So it looks like when x is negative 3, this inequality statement is true. And what's more, anytime these values are less than or equal to negative 3, they always work. So you might be thinking, well, goodness me, how am I supposed to remember that? Well, here's the deal. What happened is this. I started with a negative x, and it was greater than or equal to 3. If I divide by a negative 1, I'm dividing to make that into a positive x, so you have to change the direction of the inequality sign. And that's not the only example. I'm going to do one more example. If I had negative 2/3 x is less than, let's say, negative 8, I would multiply by a negative 3 over 2. But once again, I'm multiplying by a number over the inequality sign. So these are going to simplify to 1. Because I'm multiplying by a negative, I'm going to change the direction of my inequality sign. 2 goes into a negative 8. Negative 4 times negative 3 is a positive 12. So that's it. My point is this. When you are multiplying or dividing over an inequality with a negative number, you change the direction of the inequality sign. And I'm sorry for that last bit. All right, that's it.